Hi everybody, in this video we are going to discuss about how to do insert beginning in a circular linked list. So let us consider a circular linked list with 5 nodes like this, and if we are going to insert a new node with a data part 7, how we can do? Actually we have to make 3 things. Let us do this one first. Okay, that is the new node's next part should be having the address of the current first node. Why? Because after insertion, this new node will become the first node of the circular linked list, and the current first node will become the second node. So this connection I have to establish, and let me mark it as number 1, and number 2 should be I should make the next part of the last node to contain the address of the new node, because hereafter the new node will be the first node of the circular linked list. As per the concept of circular linked list, the last node of the list should contain the address of the first node. Okay, so this will be the new first node, so the address of this node should be stored. So this should be number 2, and number 3 will be I have to move the head from the old first node to the new first node. This one I have to make. While we are making these changes, we have to be very careful that we preserve this order. I should not change the order. For example, that is particularly the order between 2 and 3, I should not change it. Suppose if I move the head before doing the change for the last node, then I'll be in trouble. Why? Because in a circular linked list, I'll be identifying the last node only by checking whether the next part of the node is equal to the head, right? Head means the old head. That's what the current head value should not be changed before I locate the last node. So I can have a temporary pointer and I will be moving the temporary pointer while temp is not equal to the head. I should use that particular condition to locate the last node. So I should not move the head before I locate the last node. So this connection I should establish, then only I should move the head. So whenever we are working in linked list, we should be very careful that the order of changes are properly done, otherwise our code may fail, it may break, right? So let us formally write the algorithm. Before we formally write the algorithm, one more thing I want to tell. Suppose if the list is empty, how do we represent empty list? Is head will be equal to null, right? So in this case you will be creating a new node, and it is let us assume that it is having the data as 5. Now how should it look like? Head should be made to point to this new node, that's fine. And what about the circular property? The circular property says that the next part of the last node should contain the address of the first node. But when you consider a list with only one element, that is the first node and that is the last node as well. Okay, so you have to make the next part of that particular node to contain the address of itself. This is an exceptional case that we may have to consider separately, right? So when you write formally the algorithm, you first use the create node function to get the address of the newly created node. You create the node using this function and you get the address in a variable new underscore node. And you check if new underscore node is null. If it is null, then you will return false. This is the case when memory could not be allocated. Otherwise, you will proceed, and this is an exceptional case that we may have to check as we discussed. So if list is empty, then you are going to make the next part of the new node to hold the address of itself and make head to point to the new node and return true. If the list is not empty, then we have to follow the 3 steps. So first you declare a pointer. Okay, before doing that, I am just making the next part of the new node to contain the address. Whatever I have written as 1, that is next part of the new node to contain the head, right? And then you declare a temporary pointer and you move the temporary pointer to the last node and you make the next part of the last node to contain the address of the new node. That we have to make, right? You have to make this. And then the third step tells that you have to make head to point to the new node. Third step of this particular process. Okay. As a whole, this is the 8th step of the algorithm. Let us implement this algorithm in C++. And we have got 3 files as usual, and this H file contains the declaration of the insert beginning function that we can see. Since this is OOP programming, object oriented programming, the list will be coming implicit, so we have to pass only the data. Okay, so it will take an integer, and we are going to write in cll.cpp. Return type will be bool, and it's part of the class, so write it in the scope of the class, and then you write insert beginning. Okay, let it be D. So what does the algorithm tell? You have to call the create node function. Okay, so before that, let me declare the required pointers, new node, and temp also we can declare. Okay, and then we will be telling new node is equal to create node, right? You have to pass the data part, so D, and if new node is null, right? If new node is equal to null, you have to return false. Okay, done. Otherwise you are going to proceed. You have to consider first the exceptional case if the list is empty. Okay, if the list is empty, okay, no, is empty. If the list is empty, then we have to make the next part of the new node to contain the address of itself, right? So new node next is equal to new node, right? This one we have to make, and then we have to make the head to point to the node, right? Head is equal to new node, right? And you return 1. Sorry, we have boolean in C++, so no problem, we can return true. Otherwise you are going to proceed, and you will tell temp is equal to head, right? You make it to the temp to point to the first node, and you have to move till the last node. How will we identify the last node? The next part of the head will be equal to head. Yes, next part will be equal to head. I have made a mistake. While temp next not equal to head, right? I have to move the temporary pointer. I have to tell temp equal to temp next. Okay, and then you have to make the next part of the last node to have the address of the new node. Now temp will be having the address of the last node, right? Now you have to tell temp next is equal to new node, right? This connection is done, and you have to make head to point to the new node. So head equal to new node, and you return true. Successful insertion. Okay, I hope the insert beginning is done, but to check whether insert beginning is properly done or not, we need a printless function, isn't it? So we have to implement that also before we compile and check the code. So let us discuss how we can make the printless function. If there is a circular linked list like this, when I want to print, what I will do generally in a linked list, I will declare a temporary pointer, make it to point to the first node, and I will be moving till the last node and doing something, isn't it? Printing basically. So let me initialize the temporary pointer to the first node, and I'll be printing the data part, right? I'll be moving to the next node, data part, and so on. And in the loop, I should tell while temp next not equal to head, right? Till the last node is reached, I'll be printing the data parts. Okay, and the loop will break as soon as I reach the last node, right? There is a reason for that. I cannot tell while temp not equal to head, right? Because I will be initializing temp equal to head. There is a difficulty. If you try it by yourself, you will definitely understand. So our loop will be while temp next not equal to head, right? Basically the body of the loop will not get executed for the last node. We have to do it separately. That's the idea. Okay, and one case that we may have to consider is when the list is empty. If the list is empty, it's better to check in the beginning and return immediately. Otherwise we may get segmentation fault if we try to derefer the null pointers. So this will be the formal algorithm. If list is empty, then you return. Otherwise, you declare a temporary pointer, make it to point to the head. While temp is not in the last node, you have to repeat 4 and 5. In 4, you are printing the data part, and in 5, we are moving the temp to the next node. And this is the thing I told you. There is step number 6. You print the data part of the last node and return. Okay, so let us implement this print list in C++, right? The return type will be void, and it is in the scope of the CList class. So let us write it, and print list. Okay, we have to have a temporary pointer. You have to initialize, that is first make temp to point to the first node, temp equal to head, right? While temp next not equal to head, we have to do two things. One is print the data part of the temporary node. Okay, and you have to tell temp equal to temp next. And you can also have here telling some message. Okay, so when we are in the last node, the body will not be executed, so we have to explicitly tell cout temp data. Okay, and fine. Okay, so let us check the code. Let us go to the terminal and try compiling it. So G++, we have to tell cll.cpp. we need only compilation, and redirect the output to cll.o, right? Okay, fortunately there are no errors. Then cll underscore application.cpp, again once again it is compiled, and output let us redirect to cll.a.o. fine. Now let us invoke the linker using the object files. Okay, done. Let us try executing it. Okay, so now successfully you can see that printing list 1. Actually we inserted only one data. You can see the application file. I have called insert beginning only for 1. Now let us uncomment the next line. So you will be inserting 1 first, followed by 2. Since this is insert beginning, 2 will be in front of 1. So the print function should print 2 and 1, right? During compilation we have to compile. It's enough only if we compile the application file, because we have not made any changes in the cll.cpp, isn't it? So it's enough if you do this and you do the linking and you run it and see. Okay, I'm getting segmentation fault. I may have to check my code. 1 minute. Let's check it. Yes, the problem is here. Actually, in insert beginning we discussed that if the list is empty, then we have to do this, and if the list is not empty, we have to do 3 things. The first thing we discussed was the next part of the new node should be equal to head. I missed the line, because of that only I encountered trouble when I was doing the second insertion. First insertion worked fine, because this was the condition. That condition is fine, but when the list is not empty, I missed this line. Okay, so I will show it in the discussion of our diagram. Actually we have to make this connection, isn't it? I didn't make this connection, because of that I got segmentation fault. Now it is done. Okay, this is step number 1, and these codes will take care of step number 2. This is step number 3 that we have to do. Okay, so now let us try compiling the code. Now I have to compile the cll.cpp code also, right? Because I have made changes in it. So cll.o, cll application dot cpp, only compilation, redirect output to cll.a.o, right? And then invoke the linker, okay, cll.o, clla.o, right? And you give out, yeah, now it's printing both, successfully inserted. Now let us uncomment this line. I will be inserting 3 also, so I expect my code to print 3 to 1. Now I will compile only the application file, link both the files and execute it. Yes, you are getting 3 to 1, that's fine. And now uncomment this line and try out, find, link it, and then try it. Okay, so the code will be shared in the GitHub and you can try it by yourself. Thank you.